There's a group of people living today in the mountains between France and Spain who speak a language related to nothing else on Earth. No one knows where they came from. No one knows how their ancestors survived when almost every other Stone Age population in Europe was wiped out and replaced. And when scientists finally sequenced the DNA of Britain's oldest bloodlines, they found something impossible. The closest genetic relatives of one part of Britain weren't in England, weren't in Scotland, weren't anywhere near the British Isles at all. They were those same mountain people, 600 miles away, cut off by an entire country, a mountain range, and thousands of years of history that nobody could fully explain. To understand why this discovery mattered so much, you have to go back to a question that had quietly bothered historians and geneticists for more than a century. Who are the British people, really? For generations, the story taught in schools was simple enough to fit on a single page. Ancient Britons lived on the island first, then the Romans arrived and built roads and forts. Then, after Rome collapsed, waves of Angles, Saxons, and Jutes crossed the North Sea and pushed the old Britons into the western and northern edges of the island. Later came the Vikings, raiding and settling along the coasts. Later still came the Normans, who conquered the whole country in 1066 and reshaped its language and its ruling class. Each invasion, according to this story, left behind a fresh layer of foreign blood, like sediment settling on a riverbed. By the time you reach the present day, so the thinking went, the English were mostly Anglo-Saxon, the Welsh and Scots were the descendants of the Britons who had been pushed aside, and everyone carried a noticeable trace of Viking or Norman ancestry, depending on where their family happened to live. It was a tidy story. It matched the history books. It matched what people wanted to believe about their own regional identities. And for a long time, nobody had the tools to actually test whether it was true. That changed with a study that would eventually become one of the most detailed genetic surveys of any national population ever attempted. Researchers at Oxford, working under geneticists Peter Donnelly and Walter Bodmer, set out to do something remarkably careful. They didn't just want DNA from British people. They wanted DNA that could act as a kind of time capsule, a snapshot of what British ancestry looked like before the modern era scrambled everything with trains, cars, and mass migration to cities. So they recruited more than 2,000 people from rural parts of England, Scotland, Wales, and Northern Ireland, but with one strict condition. Each participant's 4 grandparents all had to have been born within about 50 miles of each other. That single requirement meant the DNA being studied reflected ancestry that had been rooted in the same small patch of land for generations. Long before anyone in the family had the chance to move to London, marry someone from another country, or otherwise mix the genetic picture. On average, the grandparents of the people in this study had been born around the year 1885, which put the genetic snapshot solidly before the upheavals of the 20th century. Once they had this remarkably pure sample of local British ancestry, the researchers needed something to compare it against. So they gathered DNA from more than 6,000 people across 10 different European countries, originally collected for an unrelated study on multiple sclerosis, and used it as a continental backdrop. The idea was elegant. If pockets of ancient ancestry still existed inside Britain, hidden underneath centuries of later invasions and admixture, then comparing British genomes to a wide net of European populations should reveal exactly where those hidden threads led. Instead of looking for single genetic mutations, which can be noisy and unreliable, the team used a more powerful method. They looked at long stretches of DNA, patterns of genetic markers that travel together because they were inherited as a block from a shared ancestor generations back. Think of it less like matching individual puzzle pieces and more like matching entire chunks of a picture at once. This method, sometimes called chromosome painting, let researchers detect subtle relationships between populations that older techniques would have missed entirely. When the results came back, even the scientists running the study were stunned. Britain wasn't one genetic population with some regional noise. It broke apart into 17 distinct genetic clusters, each one corresponding with startling precision to real geography. People in Cornwall formed one tight, distinct cluster. People in Devon, just across the River Tamar, formed a completely separate one, and the genetic boundary between them lined up almost exactly with the modern county border. A border that has existed on maps for hundreds of years for entirely different reasons. Orkney split into 3 separate genetic groups. Northern Ireland showed clear structure of its own. And running underneath the whole map was a pattern that nobody had fully appreciated before. Pockets of ancient British ancestry, holdouts that had somehow avoided being overwritten by later migrations, sitting quietly in specific corners of the island. Then came the comparison to the European mainland, and this is where the story takes its strangest turn. The researchers cross-referenced their 17 British clusters against 51 distinct genetic groups they had identified across continental Europe. Most of those 51 groups, it turned out, had contributed essentially nothing to the modern British gene pool. Only about 9 of them showed a meaningful genetic signature inside Britain at all. The English clusters lit up with clear, Continental influence, roughly a quarter linked to ancestry from what is now Germany, and a striking amount, around 45% by some estimates, linked to ancestry from what is now France, dating back to long before the Norman invasion of 1066. That alone overturned a piece of popular history. The story of the Norman conquest bringing French blood into England turned out to be far less important, genetically, than an older and much less dramatic flow of people across the Channel centuries earlier. When the team looked at where the deepest, oldest strand of British ancestry survived most strongly, the answer kept pointing toward Wales. Compared to almost every other part of Britain, Welsh genomes showed the least evidence of dilution from the later Anglo-Saxon, Viking, and Norman migrations. In other words, if you wanted to find something close to what the original post-Ice Age population of Britain actually looked like, genetically, before any of the famous invasions that fill up the history books, Wales was your best remaining window into that world. And then the researchers asked the obvious next question. If Welsh ancestry represented something closer to Britain's original genetic layer, was there anywhere else in Europe that showed a similar signature? Anywhere that might have branched off from the same ancient population thousands of years ago and then stayed relatively undisturbed ever since? The Basques live in a rugged, mountainous region straddling the border of northern Spain and southwestern France, an area with its own fiercely maintained culture and, most famously, its own language. Basque, or Euskara, is not related to Spanish, not related to French, and not related to any other language spoken in Europe today. It isn't even part of the Indo-European language family, the enormous linguistic tree that includes English, French, German, Russian, Hindi, and hundreds of other languages spoken from Ireland all the way to northern India. While almost every other language on the continent can be traced back, however distantly, to a shared ancestral tongue that spread across Europe with later migrations, Basque stands almost completely alone. A linguistic island, surrounded on all sides by languages descended from a much later wave of settlers. For a long time, linguists and geneticists alike had suspected there was something unusually old about the Basque people, something that set them apart from their neighbors in a way that went beyond just an unusual language. Classical genetic studies going back decades had already flagged the Basques as statistical outliers compared to the rest of Europe. Some scientists floated the idea that Basques might be, in some meaningful sense, a living remnant of the population that occupied southwestern Europe before farming arrived and reshaped the continent's genetics almost completely. It was an intriguing hypothesis, but for years it remained difficult to prove with real data. The Oxford study gave that hypothesis new and unexpected support from a direction nobody had specifically been looking in. When Welsh genetic ancestry was compared against the broader European map, the strongest, most specific external connection wasn't with the Bretons of northern France, who share a Celtic linguistic heritage with the Welsh. It wasn't with the Irish, who share deep cultural and historical ties. It was with the Basques, a population separated from Wales by the entire length of France, a completely different language family, and, as later research would help clarify, thousands of years of independent history. This finding lines up with an even older thread of genetic detective work centered on mitochondrial DNA, the type of DNA passed down almost unchanged from mother to child across many generations, making it especially useful for tracing very deep ancestry. Studies of the Basque population identified specific mitochondrial lineages, catalogued under names like haplogroup U8A, that appeared to have been present in the Basque region since the Upper Paleolithic, the tail end of the last ice age, tens of thousands of years ago. Researchers found that variants of this same lineage showed two separate expansion events, one starting in the southwestern refuge of Iberia and Mediterranean France before 30,000 years ago, and another radiating out from Central Europe around 15 to 10,000 years ago, as the ice sheets retreated and human populations began recolonizing the continent. In plain terms, some of the very oldest human genetic material, still detectable in Europe, survived in the exact region the Basques still call home today, and closely related lineages spread outward from there as the ice retreated, potentially reaching as far as the British Isles. To really appreciate why that matters, you need to picture what Europe actually looked like at the end of the Ice Age, roughly 15 to 20,000 years ago. For most of the preceding tens of thousands of years, huge portions of northern Europe, including almost all of the British Isles, were simply uninhabitable, buried under thick sheets of ice or locked into a frozen tundra landscape that could barely support human life. Human populations that had managed to survive the depths of the Ice Age in Europe did so by retreating into a handful of warmer, more sheltered pockets, refuges where the climate remained survivable, even as everything around them froze. One of the most important of these refugees was exactly the region that is now home to the Basque country and the wider Franco-Cantabrian area of southwestern France and northern Spain. As the ice began to melt and the climate slowly warmed, these refugee populations didn't stay put. They expanded outward, following the retreating ice northward, recolonizing land that had been empty or barely populated for millennia. Genetic studies of ancient remains show that some of the very first people to reach the British Isles after the ice retreated carried ancestry linked to exactly this kind of population, a group geneticists now refer to as Western hunter-gatherers. This is where one of the most remarkable individual discoveries in British archaeology comes into the picture: Cheddar Man. Cheddar Man is the name given to the skeleton of a man who died roughly 10,000 years ago in a cave in Somerset, in southwest England. Discovered back in 1903, his remains represent the oldest essentially complete human skeleton ever found in Britain. For most of the 20th century, Cheddar Man was something of a curiosity, a very old set of bones with no way to unlock the deeper story hidden inside them. That changed when scientists at the Natural History Museum in University College London carried out a full DNA analysis of his remains, drilling carefully into the skull to extract preserved genetic material that had somehow survived intact for 10,000 years inside the cool, stable environment of the cave. What they found rewrote the assumptions people had carried for decades. Cheddar Man's genetic profile placed him firmly among a wider group of Mesolithic-era Europeans whose remains have also been analyzed in places as far apart as Spain, Hungary, and Luxembourg, all part of that same broad Western hunter-gatherer population that had spread out from refuge areas like the Franco-Cantabrian region after the ice retreated. And in a detail that captured global headlines, his genetic markers indicated that he likely had dark skin alongside strikingly blue eyes, a combination that overturned the older assumption that pale skin had always been the norm in ancient Britain. It turns out, lighter skin pigmentation spread through European populations much more recently than most people had assumed, arriving with later migrations rather than being present from the very start. Today, geneticists estimate that only around 10% of indigenous British ancestry can be traced directly to this very early hunter-gatherer population, and even most of that fraction arrived indirectly, carried in through later waves of continental European ancestry, rather than surviving as a direct, unbroken line from Cheddar Man's own community. That's because Britain's population, like the rest of Europe's, was about to be transformed again, and this time far more dramatically. Around 6,000 years ago, farming reached the British Isles, brought by migrating groups whose own ancestry traced back to Anatolia, the region that is now Turkey. These early farmers didn't simply introduce agriculture to existing hunter-gatherer communities, who then gradually adopted new habits. Genetic evidence tells a more dramatic story. Within the space of just a few hundred years, these incoming farming populations effectively replaced more than 99% of the existing hunter-gatherer population in Britain. It wasn't gradual cultural blending so much as a near-total genetic turnover, one population overwhelmingly displacing another in a remarkably short window of time. And yet, even that wasn't the final chapter. Because if you trace modern British ancestry back far enough, you don't mostly descend from those Anatolian-derived farmers either. Another wave was coming, and it would prove just as dramatic as the one before it. Around 4,500 to 5,000 years ago, a new population began expanding out of the vast grasslands of the Russian and Ukrainian steppe. Archaeologists call this culture the Yamnaya, and their descendants, known through their distinctive core-decorated pottery, are often referred to as the corded ware culture, or in the specific context that reached Britain, associated with the Beaker phenomenon, named for a distinctive style of bell-shaped drinking vessel found buried alongside them across huge stretches of the continent. This steppe-descended population carried a genetic signature that had been almost entirely absent from Europe up to that point, and their arrival is now understood as one of the most consequential population events in the continent's entire prehistory. When these Beaker-associated steppe-descended migrants reached Britain, roughly around 2400 BC, they didn't simply settle alongside the existing Neolithic farming population. Genetic evidence gathered in recent years, including major studies published in the journal Nature, indicates that this new wave replaced somewhere in the region of 90% of Britain's existing Neolithic ancestry within just a handful of generations. To put that in perspective, the population that had painstakingly built Stonehenge, one of the most sophisticated and labor-intensive monuments of the ancient world, was largely gone, genetically speaking, within a few centuries of the monument's completion. It's a genuinely strange thought. The people descended from the ones who built that iconic stone circle were, to a significant extent, replaced by newcomers not long after the final stones were put in place. Researchers studying this transition have offered several possible explanations for how a replacement on this scale could have happened so quickly, ranging from the spread of disease, since some evidence suggests these migrating populations may have carried strains of plague, to more straightforward explanations involving superior mobility, different social structures, or simply demographic momentum once a foothold was established. Whatever the precise mechanism, the genetic result is not in dispute. Somewhere in the deep background of this Bronze Age transformation, Researchers have also traced the specific pathway this migration took into Britain, identifying prehistoric wetland regions in what is now Belgium and the Netherlands as a critical staging ground before the crossing into the British Isles. Later Bronze Age population studies, some published as recently as this year, have continued to refine exactly how these overlapping waves of migration moved through northwestern Europe before finally reaching British shores. So by the time you stack all of this together, the picture of who the British people actually are becomes far stranger and far more layered than the simple story of Britons, than Romans, than Saxons, than Vikings, than Normans ever allowed for. Underneath all of those later, more famous invasions lies a much deeper and much older sequence of population turnovers, stretching back to the very first hunter-gatherers who followed the retreating ice into an empty landscape, through the near-total replacement brought by early farmers, through yet another near-total replacement brought by steppe-descended Bronze Age migrants, and only after all of that do you finally arrive at the more familiar chapters involving Rome, the Anglo-Saxons, the Vikings, and the Normans. And what the Oxford Genetics study revealed, somewhat by accident, is that this incredibly long and complicated sequence didn't erase every trace of the earliest layers completely. In certain corners of Britain, particularly in Wales, older genetic signatures survived more intact than almost anywhere else on the island, less diluted by the later waves that transformed most of England. And when researchers went looking across the whole of Europe for anywhere else that might share that same deep, ancient signature, the answer wasn't a nearby Celtic-speaking region with an obvious shared history. It was the Basque country, a population isolated by geography, by an entirely unrelated language, and by a genetic legacy that appears to reach back to one of the very refuges where humans survived the depths of the last ice age. It's worth being careful here about exactly what this connection does and does not mean. Geneticists are not suggesting that Welsh people are somehow direct, unbroken descendants of a specific ancient Basque tribe, or that the two populations maintain some secret, continuous contact across thousands of years of European history. That's not how ancient population genetics works, and it's an important distinction the researchers themselves have been careful to draw. What the evidence actually suggests is something more subtle and, in some ways, more interesting. Both populations appear to retain unusually large amounts of a very deep, ancient European genetic layer that has, for various geographic and historical reasons, been diluted much more heavily almost everywhere else on the continent. Wales, tucked into the western edge of Britain, and the Basque country, tucked into a mountainous corner between France and Spain, both happen to be places where later migrations had comparatively less impact, allowing older genetic threads to persist more strongly than in more exposed, more heavily trafficked regions. Other parts of Britain tell their own distinct version of this layered story. Ancient British ancestry, while less dominant than in Wales, also persists at meaningfully higher levels in Scotland and Northern Ireland than in much of England, complicating the old assumption of a single unified Celtic fringe that supposedly represents everything pushed aside by the Anglo-Saxons. Researchers found the reality was more fragmented and more locally specific than that. Distinct pockets of ancient British genetic identity appeared to correspond to old post-Roman kingdoms that most people have never even heard of, places like Reged in what is now Cumbria in the northwest of England, Elmet in what is now north-central England, and Dumnonia, the ancient kingdom that once covered Devon and Cornwall. These were small, independent Celtic-speaking kingdoms that held onto their own separate identities for centuries after Rome withdrew from Britain. And remarkably, their rough geographic boundaries still show up today as detectable genetic clusters, essentially fossilized on a modern map through inherited DNA. Meanwhile, some of the invasions that loom largest in popular imagination turn out to have left surprisingly modest genetic footprints. The Vikings, despite centuries of raiding, conquering, and settling along British coastlines, left comparatively little detectable DNA behind in most of the areas they're famous for occupying. Meanwhile, some of the invasions that loom largest in popular imagination turn out to have left surprisingly modest genetic footprints. The Vikings, despite centuries of raiding, conquering, and settling along British coastlines, left comparatively little detectable DNA behind in most of the areas they're famous for occupying. The Romans, despite roughly 4 centuries of occupation, administration, and military presence across much of Britain, left an even smaller genetic signature, essentially blending into the background rather than reshaping the population in any dramatic, lasting way. Even the story of the Norman conquest, often treated as the definitive turning point that reshaped English identity, turns out to be genetically overshadowed by an earlier, much less dramatic, much less discussed flow of people across the Channel from what is now northern France, one that had already been unfolding for centuries before William the Conqueror ever set sail. There's another layer to this that makes the Basque connection even more striking once you understand how genetic isolation actually works over long stretches of time. Most human populations don't stay isolated. They trade, they intermarry, they get conquered, they migrate, And all of that constant mixing tends to blur older genetic signatures over the centuries, smoothing out distinctive ancient markers the same way footprints get erased by new snowfall. For a signature this old to survive clearly enough for modern researchers to detect it at all, a population generally needs some kind of natural barrier that slows down that blending process. Geography provides exactly that kind of barrier for both of the populations at the center of this story. The Basque Country sits wedged into the western end of the Pyrenees, a genuine mountain barrier that has historically made large-scale migration into the region more difficult than moving across open plains. Wales, similarly, is dominated by rugged uplands and a long, defensible interior that made it harder for later invaders, first the Romans and then the Anglo-Saxons, to fully penetrate and resettle compared to the flatter, more accessible regions of eastern and southern England. In both cases, difficult terrain didn't just shape culture and language. It appears to have quietly preserved genetic history that was erased almost everywhere else on the continent. This also helps explain something that puzzled linguists long before geneticists got involved. Basque isn't the only language in Europe with unusual, hard-to-classify roots, but it is by far the most extreme example of a language that simply doesn't fit into the dominant Indo-European family that swept across the continent starting several thousand years ago. Many linguists now believe that before Indo-European languages spread outward, likely carried along with those steppe-descended Bronze Age migrations discussed earlier, Europe was home to a much wider variety of older, unrelated languages, remnants of the diverse populations that had resettled the continent after the Ice Age and then spent thousands of years developing their own distinct ways of speaking. Almost all of those older languages were eventually pushed out, absorbed, or simply died out as Indo-European languages spread and dominated. Basque appears to be the one clear survivor of that older linguistic world, a language that never got overwritten the way nearly everything around it did. That timeline lines up almost perfectly with the genetic story. The same geographic isolation that let an ancient pre-Indo-European language survive intact in the Basque Country also appears to have let an unusually old genetic signature survive there too. Two separate lines of evidence quietly pointing toward the same underlying history. None of this means the story is finished either. Ancient DNA research has advanced dramatically just in the years since the original Oxford study first made headlines, and newer techniques keep refining and complicating the picture further. Researchers working on remains from sites like Gough's Cave and Kendrick's Cave in Britain have identified evidence of at least two genetically distinct groups of people who recolonized the British Isles at the very end of the Ice Age, arriving from different directions with different cultural traditions, only for one of those early groups to seemingly vanish from the genetic record within a few hundred years as the climate and environment shifted again. Other recent studies have gone even further back, sequencing DNA from remains scattered across Bulgaria and the Czech Republic that are more than 45,000 years old, revealing that some of the very earliest modern humans in Europe carried noticeably more Neanderthal ancestry than any population alive today, and that these earliest arrivals aren't even directly related to the later populations that eventually settled the continent for good. Each new discovery adds another layer to an already complicated picture, and each one reinforces the same basic lesson. The genetic history of Europe was never one smooth, continuous story. It was a long, messy sequence of populations, rising, spreading, colliding, and in many cases nearly disappearing altogether over and over again for tens of thousands of years, long before anyone started writing any of it down. All of which brings the story back around to that original, striking discovery. When scientists set out to methodically compare the deepest ancestry hidden inside British DNA against every population they could sample across the European continent, the vast majority of connections lined up more or less where you'd expect, matching the well-documented history of migration, conquest, and trade that fills the history books. But one relationship stood apart from all the rest, a genetic echo connecting one corner of Britain to a small, mysterious, language-isolated population living in the mountains between France and Spain, a population whose roots appear to reach back to one of the last refuges where humans clung on through the depths of the Ice Age. It's a connection that has nothing to do with any invasion, any conquest, or any war recorded in any history book. It reaches back further than the Romans, further than the Celts, as most people imagine them, further even than the first farmers who transformed the British landscape thousands of years before Stonehenge was ever built. It reaches back to a time when nearly all of Britain was empty, frozen, and uninhabitable, and the very first people brave or desperate enough to follow the retreating ice northward carried with them a genetic signature that, against every likelihood, still echoes faintly today in two of the most unlikely places imaginable, an isolated mountain region on the border of France and Spain, and the green, rugged hills of Wales, 600 miles and tens of thousands of years apart, yet still, in some deep and quietly remarkable way, connected.